Number one, Claire has a recipe for yellow cake. She uses 9 1/3 cups of flour to make 4 cakes. Noah will follow the same recipe. He'll make C cakes using F cups of flour. Which of these equations represent the relationship between C and F? Okay, so excuse me. I know that this is the key information, and we have 9 1/3 cups of flour per 4 cakes. Okay, so I know that in order to write an equation in this structure, which we have been down the road of a y equals k times x time type structure, where obviously that's what these structures are, but they're using C and F. Um, I have to figure out like what the C and F mean and kind of analyze how I'm going to do some math here. Okay, so I'm going to have a number of an amount of cake with some sort of number here times a cup of flour. Okay, so looking at all of these numbers down the middle of these equations, I'm trying to figure out like what builds these fractions, right? So if I act like I'm going to multiply by 1 cup of flour, it makes me think here that this number needs to be the amount of cake that I would get out of 1 cup of flour, right? So this is times one, number of cups of flour. So if I act as if this is one, then that has to be multiplied by something that is going to solve the amount of cake I get out of 1 cup of flour. So in that sense, I need a unit rate here that is backwards of this. Okay? I need to figure out 1 cup of flour gets me how much cake based on the way this is set up. Okay? So you just have to analyze and actually have to test some things out in order to do that. So what I'm excuse me. What I'm going to do to figure that out is I'm going to flip this. I have 4 cakes divided by 9 1/3 cups of flour. Because remember, the bottom number when we actually divide this is the one that turns into 1. Okay? So I now have to think. I'm doing 4 divided by 9 1/3, which isn't easy because these are still in fractions. So I need to keep this in fraction form. So this is going to be some hefty fraction work for us. Okay? So I'm first going to do 4 as a fraction, which is 4 over 1. And to do division with fractions, it's KCF, which means keep, change, flip. So that's going to be multiply. And I can't flip this until I have it as a mixed number. So 9 1/3 is 9 times 3, which is 27, plus 1 is 28 over 3. So that is the improper fraction of 9 1/3. 9 1/3 is the same as 28 thirds. So that's what I have to flip. That is 3 over 28. Now I can multiply straight across. So 4 times 3 is 12. 1 times 28 is 28. And that can simplify. And I keep using this as multiple choice. So I'm looking at some of these fractions. There's a smaller number on top, bigger number on bottom. So that cancels out A. That cancels out D and leaves these two as possible options with smaller numbers and bigger numbers on top. Okay. But if I'm thinking about what numbers would work here, 3 does go into 12 and 7 goes into 28. They both go in there 4 times. So to simplify, dividing by 4, that turns into 3/7. So again, going back to this fraction that we had at top, that is 3 3/7 cake for 1 cup of flour. That's the unit rate that I solved. So now imagine if I used 1 here, okay? 1 cup of flour times 3/7 is 3/7 cake. So that fits this scenario, okay? So it takes a little trial and error on this one, but C is the correct answer. A graduated cylinder actually contains 7.5 milliliters of water. When Han measures the volume of water inside the graduated cylinder, his measurement is 7 milliliters. Which of these is closest to the percent error for Han's measurement? Okay, so remember, percent of error is going to be the amount we are off on top divided by the actual number on bottom. Okay, so it actually holds 7.5 milliliters. When Han measures the water inside a graduated cylinder, he measures 7 milliliters. So it actually uses the word actual up here. Okay, so that's the actual amount. So the amount off is the difference between 7.5, which is the actual, and 7, which is the amount off is only 0.5. And the actual is 7.5. Okay, so this is one that we could pull the calculator out. We can do 0.5 divided by 7.5, and we are looking at, oh boy. Okay, I apologize. I paused the video there for a second because I caught a typo. I could tell that the answer wasn't right, so I didn't get this decimal typed very well the first time, and we have to be careful with calculators, so that's why I'm talking about this in the video. So accidentally did 5 divided by 7.5, and that gave me the wrong answer, so we have to be careful with the decimals when we're typing. So as you can see here, this is what comes up in my calculator, which I have to move the decimal twice because, as you can see, I'm solving percents, right? If I'm solving actual percents, you got to move the decimal over twice, which would be 6.6 is repeating, and you can see that I have one answer there that would be appropriate for that. Number 3. It takes Diego 1/24 of an hour to complete a lap on a circular bike track. The track is 1/3 mile long. What is Diego's bike speed? Okay, so we're doing miles per hour, so I can think of the fraction, right? Miles per hour. Okay, and Diego traveling 1/24 of an hour, or taking, 1/24 of an hour to complete the track of 1/3 mile long. Okay, so I'm going to just get those organized here. The number of miles is 1/3 miles in 1/24 of an hour. Okay, so as you got to be careful here, I see some miles per hour and hours per mile. So I'm going to try to solve this in miles per hour and see what we get. So again, anytime I actually divide these, remember it always turns the bottom into 1, right? So what I'm doing here is, again, taking 1/3 divided by 1/24, and then I need to keep change flip. So 1/3 times 24 over 1, which turns into 1 times 24 is 24. 3 times 1 is 3. Okay. And then remember that simplifies because 24 over 3 is the same as division. 24 divided by 3 is 8. Okay. So the rule of finding the unit rate, we actually divide the top by the bottom, which we did, which means we solved 8 miles in 1 hour. Okay? 8 miles per 1 hour. A practice field is 250 feet long. The game field is 40% larger than the practice field. How long is the game field? So I'm automatically going to split this in half because there's 2 ways to do this. Okay? Remember that there's a 2-step way to do this and a 1-step way to do this. So I'm going to show both. So I need to solve 40% of 250. Okay? But I have to increase by that amount, so that's where the 2 steps come in. So remember, man, sorry. Remember when we are doing of, that's multiply, and it's multiply using this as a decimal. So 40% as a decimal is 40. So I'm coming down here, 250 times 0.40. 250 times 0.4 equals 100. Okay. But let's remember that we're increasing by that much. So I have to come back and add my original 250, which looks like I am at 350 feet. Okay. The 1-step way is to remember that if I have 100% of the original and I'm adding 40% to it, that is 140%, which as a decimal is 1.4. Okay, so if I take my 250 times 140% as a decimal, which is 1.4, to prove to everybody that this works. So instead of times 0.4, I'm doing 1.4, and I get my answer in 1 move. Okay, 350 feet. Noah has a coupon for 30% off his favorite clothing store. He uses it to buy a hoodie and a pair of jeans. Noah paid $28 for the jeans after using the coupon. What is the regular price of the jeans? Okay, so this is one of those situations where we got to work backwards to the original price that we don't know. Okay, so I'm just going to use P for original price. If we had an original price and that was dropped by 30%, remember 100% of the original dropped by 30% is now 70%. So if I was solving this using 70%, I would have my original price, and it's not 100% of itself anymore. It is now 70%. And 70% as a decimal is 0.7. And the new price that I paid for it was 28. So original price times 70%, which is 30% off, is now $28. So something times something equals 28. So if I want to work backwards, I need to not do I have to do the opposite of times. Okay? So 28 divided by 70%, working backwards, doing the opposite. Okay? 28 divided by 70% as a decimal is $40. Okay. The regular price of a hoodie, this is a new situation, is $27. What did Noah pay for the hoodie? Okay. So now this is just, again, now that we did this up here already, we know that we're solving for 70% because that's 30% off. So I'm going to kind of use the same structure we have right here. The original price is $27, but now it's 30% off, so I'm calculating what 70% would be, which is 0.7 as a decimal. Okay. 27 times 0.7 equals 18.9, which in the money world is $18.90. If the regular price of an item is X dollars, what is the discount of the price in dollars? Okay. Now, remember when we see this, X dollars, on a test or quiz, that is the international symbol for them asking us to write an equation. So if we have this math up here, we should be able to place X into a place in order to calculate this. So if the regular price of an item is X dollars, what is the discount price in dollars? So the original is X, and we are multiplying X by 70%, because again, this whole situation is still based off of 30% off. And that is my discount price. Okay, that's what it is. X times 0.07, or if you wanted to start getting algebraic, we don't write it that way, we write it this way. 1.7x. Remember, 0.7. 0.7 is 70%, right? That's coming from all the way up here. 30% discount off of 100% is 70%, and 70% as a decimal in our calculator is 7/10. Okay. Kieran's mother gets a restaurant bill for $25. She has a coupon for 15% off. After the discount is applied, she adds 20% as a tip. Okay, so we have to kind of follow this in order. So what is the total after the discount and tip? Explain or show your reasoning. So the bill is $25. Okay, we have a coupon for 15% off, so we have to remember that $25 is our original 100%. We have 15% off, okay? And then we add, after that, when we solve this, we're going to do a 20% tip after, okay? It's kind of important that we do that afterwards, because we need a new amount before we calculate a 20%. We don't want to add that here right away. That's actually going to get us a different answer. And you could test that out yourselves. It should get you a different answer. So 100% minus 15% is 85%. So I'm going to go ahead and solve for 85%. Remember now, as a decimal though, 85% is 0.85. Okay, so I'm going to take my $25 original, solving 85% of that. So of is multiply by the decimal. So I have $25 times 85% as a decimal. Come on. 25. Nope, let me clear out. 25 times 0.85, which is 85%, and that is 21.25. Okay, so that is after my 15% discount. Now I need to add a 20% tip of this. Okay, so remember, now this is my new 100%, and I'm adding 20% tip, which is going to be 120% of the original. Okay, 120 as a decimal is 1.2. So I'm coming up here and multiplying by 1.2. Okay. Oh, where'd the calculator go? Let's see if I can find it. There we we are. So I have, sorry, let's set this up on the screen. 2125 times 1.2 is now $25 and, or sorry, 25.5, which again in the money world is $25.50. Okay. That is my grand total at the end. All right. Jada's sister works in a furniture store. Yay, Jada's sister. She earns $15 per hour. Draw attention to that. Sounds like some sort of rate I'm going to need to know. The store offers her a raise, a 9% increase per hour. Okay. After the raise, how much will Jada's sister make per hour? So she is making $15 per hour, which is the original 100%. Okay. She's getting a 9% raise, so plus 9% equals 109% in the end. 109% as a decimal is 1.09. So that's what I'm going to use for my math. So I'm solving 109% of 15. Of is multiplied by the decimal 1.09. Okay, 1.09 representing the original 100 plus the 9% is 109%. Okay. So $15 times 1.09 representing 109%. You can see in the calculator is $16.35. Okay. The store bought a table for $200 and sold it for $350. What percent was the markup? Okay. So here's what's up. When we do markups and when we calculate percents of something going up or down, that is based off of the original. But we have to take a look at how much it went up. We have to figure out from 200 up to 350, how much of an increase is that? And I, automatically can see that that's 150, right? 200 up to 350 is $150 dollar increase. Okay, but now to calculate it as a percentage. Okay, and remember, percent is a part divided by a whole. Okay, and of course those two terms change a little bit depending on the scenario we're talking about. So in this case, the part is our amount of increase. So the part is our increase, and the whole is our original, what it normally was. So that's how much of the original did we go up by. So that's $150 increase divided by our $200 original. Okay. So our $150 increase divided by the original $200. In other words, this is saying 150 is what percent of 200? It's 75%. Okay, so that equals 75%. Remembering, again, that when you solve percentages in your calculator, that decimal is going to move twice to be 75%. Okay, Jada's sister earns commission. Commission is like a percent that she earns from a sale. So she makes 35% of the amount that she sells. Last week, she sold $7,000 worth of furniture. How much was her commission? Okay, so she earns 3.5% of $7,000. Okay, so this is just straight up. There's no like increase or decrease here. It's just literally like what is 3.5% of 7,000. So I again have to turn this into a decimal 0.035 because we would need to move the decimal back twice, and there would be a 0 and a 0 there. Okay, so that's again how we turn that into a decimal. So 0.035 of $7,000 is, okay, clear, 0.035 times $7,000 is $245.